The next part of Chapter 7 concerning the transport layer, we're going to discuss TCP and UDP. First, we're going to talk about TCP communications. There are key differences between TCP and UDP, and the basic difference there is the reliability. TCP communication is obtained through the connection-oriented session, so it's a little bit more reliable. Before a host uses TCP, it sends data to another host, and the TCP initiates a process to create a connection with the destination. That way it makes sure that the destination is already there before it tries to communicate with it. Here's an example of how this communication works. We have the individual here who's trying to contact Cisco on the web. So it goes from the application, transport, internet network, and it goes over to the server and follows it back up. Then the destination accepts the connection and lets it know that yes, we're connected. You can go ahead and send your information from here. So part of the additional overhead of TCP is the network traffic. It is more reliable, but the more reliable it is, the more network traffic is generated, because you have to have those acknowledgments and the requests for retransmission if something isn't reached. So with our TCP communications that we have going on, a client sends a TCP request, and this is done through the application process, and it may run, or it does run, on servers. And a single server may run multiple application processes at the same time. These processes wait until a client initiates the communication with the request for information or for other services. So the server's kind of hanging out there waiting on it. Each application process running on the server is configured to use a port number. Typically, it's going to use recognized port numbers. The source port is going to be randomly generated or randomly assigned, but the destination port is going to be one that is typically known. And this example here shows that client 1 is requesting an HTTP request, which is a web request, and client 2 is requesting SMTP, which is email. So in step 2, you'll see that the destination ports are using well-known port numbers as the destination port for those applications. And we use random port numbers as the source port. The server response to TCP client uses the source port from the request packet as its destination port. Okay, because that's the one that it requested it, so it knows it needs to go back into that port, basically. And then the server response to TCP client uses the destination port from the request packet as the source port as well. Okay. So here we have the information. Client 1 has requested to use port 80. It comes back to the source, or client 1, and then it allows it to use source port 80 where the server is sending it from. This requesting and establishing the connection can be thought of as a three-way handshake. The TCP connection makes the establishment. It will send the request. B gets the sent information. It sends it back to client A and says, yes, I've received your information. And 3 then establishes that handshake. So we have a three-way handshake here that says, hey, I'm sending you something. I've received that. Here you go. I've got it. And then it sends it back and says, okay, now we can start talking. So we have this three-way handshake going on. Step 1, like I said, is initiating the client request to a client-server communication session with the server. Step 2, the server acknowledges the client-server communication session and requests a server-to-client communication. And then step 3 is initiating the client acknowledgement that the server-to-client communication session has occurred. If you'll notice, or if you can remember when you've used Wireshark, you may see some of these acronyms being used in Wireshark if you drill down through and look at some of the information going on. Some of the fields you have the URG, that's an urgent pointer field, significant. The ACK is acknowledgement field. You have the PSH, that's the push function. Then we have our RST, or reset the connection. You have SYN, that synchronize the sequence numbers. That's saying hello, here we go, let's get everything in order. You'll notice on the right there that the sequence number is 100. When it sends it back, it is acknowledging it at 101, and it has a sequence of 300, and then when it's established, the sequence is 101 and it's acknowledged at 301. So you see how the numbers are starting to line up. Once the communication is finished, it will send an FIN, which means that there's no more data from the sender to be sent. As I was mentioning Wireshark, here is a good example of what Wireshark is going to display for you. Here, the initiating client requests a client to serve a communication session with the server. Okay, here's our source, here's our destination. As we scroll down through here, we'll see that the TCP segment is the frame shows the SYN, or the synchronization flag set, to validate an initial sequence number. We've got a randomized sequence number valid, which is relative to 0. So here's our sequence number. Okay. Here is the random source port, and here is the well-known destination port that we are going to. Okay, so we're going to port 80, and the random is port 1061. So we've gone from our source to our destination, and now our destination becomes the source, and it's sending the information back to us. So the source port is 80. The destination port is 1061, which is the one that we created earlier. We now have our synchronized and our acknowledgement. Our sync is set to 1. And then this one is the acknowledgement for the segment in frame 10. And it gives us the information here. You'll notice that, like I said, the destination port is the 1061, which corresponds to the initial communication that we had going on, and the source port now is 80 because that's where we requested the information. Now we have the third part of our handshake. So our original source, or our client, sends information back to its original destination. Here's the sequence number and the acknowledgement number. Here's the acknowledgements it's set. Okay, so there's the three-way handshake. It did take it 3 steps, but you can see all of this in Wireshark, and that's a neat little tool that you can use. You'll want to have it in your arsenal of information that you can continue to use throughout this course and the other courses in this program, and also when you get out into the real world, it is some information that you can use. Now it's time to end our communication. So we have to have a two-way handshake here. If you'll recall, we talked about having the fin, or the finish, and the acknowledgement, so that our client sends its information saying, hey, I'm done, and then the receiving end acknowledges that they've received that. The initiating client doesn't send it back again. That would be a little redundant. So we have our three-way handshake. Then this says, I'm finished. He says, I acknowledge that. He sends a finished, and he says, I've acknowledged that as well. You can also see that here inside of Wireshark. Here, a protocol analyzer shows the details of frame 16, which is the finished request, which is here. Let's scroll down through here. You'll see that the flag has been set to finish and acknowledge. And the protocol analyzer also shows in frame 17 the TCP acknowledgement response. Okay, so it's acknowledged, it's set, and it is done. It is possible to terminate the connection by a three-way handshake. when the client has no more data to send, it sends the finish to the server. And if the server has no more data to send back to the client, it can reply with both the finish and acknowledgement flag sets, combining the two steps into one. And the client just responds back with he acknowledged that he received that information. There is a lab on TCP Communications. There's also this activity that I would suggest that you go over several times until you are able to complete the task and you understand how this communication is working.